You're hanging with Hussick, and this video is about amines, the organic family, and what do they contain, why they contain this functional group right here. When it's terminal, it's NH2, and it's called the amino functional group, so let's have a look at them. Okay, so amines are actually important to biological molecules, and as we'll see in a subsequent topic, they combine with carboxylic acids to form really important molecules called amino acids, which build all the proteins in all living things. So boy, are these important. But let's start with the amines. So amines contain the NH2 functional group. And actually, as it says down here, this is a terminal functional group, which means it's on the end. It's found on the end of a molecule, okay? These are basic or alkaline, which means if you have amines in solution, they're going to have a pH greater than 7. Now, this might not mean that much to you depending on your background in acids and bases, but it's fundamentally important to the nature of the compounds that they're alkaline or basic, okay? They also contain hydrogen bonding capability because they have an N bonded to an H, and as you probably remember, N, O, or F bonded to H means that it can make a hydrogen bond to the neighboring N, O, or F of a neighboring molecule, and it can form a hydrogen bond. This also means that they're water soluble, okay? Because remember, like dissolves like. So since water is polar, did I even write that they're polar? Yeah, they're polar, obviously. Polar. Like dissolves like. So since water is polar, it will dissolve other polar molecules, especially small polar molecules like small amines. So we'll go through how to name them and how to draw them. Okay, so I'm going to use this general structure here to show you a couple things about terminal amines. Okay, one is that I'm again using this R group notation. That's just referring to like a string of carbons, you know, it's attached to carbons basically. Okay, so R is representing a carbon chain. And then not to forget the nature of a nitrogen atom, like this, is that it wants to make 3 bonds and it has a lone pair. Okay, so what does that mean for nitrogen here and the bond angles? Remember that as soon as you put that lone pair in, the bond angle here, or the bond angle there, whichever you want, it goes down from the usual tetrahedral 109.5, and it goes down to around 107.3 degrees. Okay, so don't forget the impact on the bond angle. In terms of the name, we call these amino, we use the prefix amino whatever, or sometimes the other way is to use the suffix amine. Okay, so I'll show you both ways to do this. So if you've got a 1 carbon amine like this, da 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 da. Again, the carbon is 1, so it's a meth. So this is either called methanamine, or it is called aminomethane. And I think the preferred naming is this one, aminomethane, okay? If we have a 2 carbon, it would be, this is maybe a little bit redundant, but I'm doing it anyways because I started drawing it, aminoethane. Okay, not too complex. If you have a ring structure, why not? Get a ring structure going here. If I can draw one, I'm kind of struggling, but if I can draw one, it's like chicken scratch down here. There, finish the ring. Holy cow. There we go. So we've got a 3 carbon ring, so we know that that's cyclopropane, isn't it? And all the bonds are single. So we would just call this aminocyclopropane. There's no need to give the position because like all functional groups, this one gets priority, so this becomes carbon 1. So that would just be 1 aminocyclopropane or just aminocyclopropane. Works just fine. How about another one with a little offshoot group, with a little branch? Okay, really gonna get crazy here. Okay, so there's your NH2. Can fit 1 hydrogen there. Let's put a methyl group down there. We can fit one hydrogen there. So this would be called 2-methyl amino. Whoops, I can't even spell it. Aminopropane. Okay? Or alternatively, it would be called 2-methylpropanamine. Okay? Why carbon 2? Well, remember the carbon 1 is going to be the one with the functional group getting priority, and then carbon 2 is going to be that one right there where the methyl group is. Remember that whenever you have, it just follows all the rules of before. Whenever you have a ring structure, the ring becomes the parent structure. Okay? Hopefully this helps you recognize amines and name amines. And we'll go from there.